Okay, so let's run through and just do an overview of this activity. So the first part, we're learning about climate change, right? And so hopefully you watch this video and understand that this should not be a political decision. We should be basing it on data. And that there are certain things that science can't answer, right? Like your moral obligation to do something. And so that's just my little spiel on that. So let's talk about, though, what we should learn from the data. So carbon dioxide is one of the main greenhouse gases that we have in our atmosphere. So if you're looking at this picture here, so the difference there between the yellow versus the orange is that the full sunlight is coming in, but then what it does is it radiates the heat back off that bounces back and forth between these greenhouse gases. And so we're trapping the heat in the atmosphere, which is a really good thing. It's the reason we can live here on this planet. But if we get too much, obviously it can change the climate. And so then we looked at the types of greenhouse gases. Most of the carbon dioxide coming in our environment is caused by fossil fuels. And we've actually measured this. So when we say, is it really human caused? Well, yeah, right? This is the majority of the carbon coming into the atmosphere. It is by fossil fuel use. And so, yeah, we are making a big difference in our climate. And then this little activity was just to see if you could guess. And really the point is that the scale matters, right? We can't really tell. I love it. I mean, I've heard it so many times where someone will be like, oh, there's like blizzards all over the Midwest, you know, that we're definitely not having climate change. And I think, okay, one storm doesn't say anything about the global patterns that are happening, and we love to say that, right? It's really cold today, so you know, climate change must be a hoax. But you have to look at the bigger scale. So as we look at the bigger scale, obviously you can see here, and the red line is atmospheric carbon dioxide, right? So as atmospheric carbon dioxide goes up, so does the temperature. And it's been gradually increasing over this time frame. So this is 1880 to 2010. And then we see it on a bigger time scale, so 1,000 years, and we see this dramatic increase since basically the Industrial Revolution, when we started burning fossil fuels. And then this animation, if you didn't watch it, you really should. It's really cool, and you can see how carbon dioxide levels have changed dramatically over this time frame. But if you look back, you know, way back, millions of years, you can see that we're actually in a cool spot, right? It's been much warmer, but not since our species evolved less than 300,000 years ago. And so why are people freaking out, right? That's the big question. Why do people freak out? If we've been way warmer than this before, not us as Homo sapiens, but the Earth has been way warmer than this before, why are we not freaking out? Well, it's all about rate. The time that it's taken us to get from where we were 150 years ago to where we are today is way faster than any change that's ever occurred on our planet. And so despite maybe, with the exception of maybe the meteor that killed off the dinosaurs. And so here we have tides. The tides are increasing as well, and you can see that it's not linear. We're kind of doing this exponential thing. Glaciers are decreasing too, even though every year you can look and see some different patterns, but we have to look at the overall pattern. So the idea here is that if you just look at the data, I mean, there's no question in scientists' mind, at least, that the data definitely shows that climate is that the temperatures are increasing, the globe is warming, and that fossil fuel use is a primary driver. And so then it becomes the question of, you know, what do we do about it? And that's where you come in, right? We don't know. We're working on it right now, right? But what you do about it is really up to you. And we hope that one of you someday comes up with a really awesome solution that we haven't thought of. Sorry about that. So then just looking at other threats besides climate change. So habitat loss, so this is like deforestation, desertification. So if you repeatedly farm the same land over and over again, it gets deprived of its nutrients, and then plants don't grow as well, and the desert will actually encroach upon the plants. And so you get the whole areas of cropland that are just being swallowed up by the desert. This is eutrophication, too much nutrients, too many, and you'll see this in the next activity. But if you dump a whole bunch of nutrients in, it disrupts the trophic structure, right? So certain organisms that feed on those nutrients go way out of control, like this is an algal bloom, and then what they do is they block out other organisms, and then when they die, you get this massive decomposition that actually strips the water of all of its oxygen, and all the fish die. So it's really just a trophic imbalance when you add nutrients in. This is from like fertilizer. We see this happening in Utah Lake every year. This is an introduced species. We talked about this before in class. You know, you introduce them and then they didn't normally thrive there and they didn't evolve there, and so they mess up the trophic structure. So that's the gist of this activity.